writing linear functions from word problems. We'll be looking at contexts where the rate of change or the initial value will be negative numbers. A charity organization had a fundraiser where each ticket was sold for a fixed price. They had to sell a few tickets just to cover necessary production costs of $1,200. After selling 200 tickets, they had a net profit of $12,000. Let P represent the net profit in dollars when they sold N tickets. And we're supposed to write an equation to show the relationship between P, the net profit, and N, the number of tickets sold. So I like to organize the information that was given in the word problem in a table of values. And my independent variable is N, number of tickets, and my dependent variable will be P, which is the profit in dollars. And I know that if they sell 0 tickets, they have already spent money. They've spent $1,200, so they are $1,200 in the hole, as it were, if they sell 0 tickets. If they sell 200 tickets, they will have a net profit of $12,000. And so, because I know that these tickets are selling for a fixed price, this is a linear function. And in a linear function, I have y is equal to mx plus b, where m is my rate of change and b is my y-intercept. So, as far as the initial value or the y-intercept, that will be negative 1,200. And my rate of change, I don't know what that is. I don't know what the price of a ticket is, but I can figure out the change in y and the change in x to get my rate of change. All right, so the change in y. How do I get from negative 1,200 to 12,000? The change in y here is $13,200, and the change in x to get from 0 to 200 tickets is 200 tickets. So my rate of change is $13,200 divided by 200, or $66 is going to be the price of a ticket. So my equation is y equals 66x minus 1,200, but using the variables given in the problem, P, the profit, is equal to 66n, 66 times the number of tickets, minus 1,200. All right, now the next example is about a stunt driver whose name is Rachel. One time during a gig where she escaped from a building about to explode, she drove to get to the safe zone at 24 meters per second. All right, so Rachel is a stunt driver. Her rate of change is 24 meters per second. That's given, and it's a constant rate, so this is a linear function. After 4 seconds of driving, she was 70 meters away from the safe zone. Let D represent the distance in meters from the safe zone after t seconds, and then we're going to write an equation. So same thing, we're going to start with the table. We're going to put our independent variable down, which is t in seconds, and our dependent variable is D, the distance from the safe zone in meters. At 0 seconds, she is farthest away from the safe zone, but I don't know how far away it is, right? It says that after 4 seconds, she is 70 meters away from the safe zone. And because this is a linear function, we can use y equals mx plus b. And now what I want to think about is what would the graph of this situation look like? So I would have my time on my horizontal and distance on my vertical axis. And at 0 seconds, she's a certain distance away from the safe zone. But after some time, she finally makes it to the safe zone. So can you see this slope, this rate of change is negative, right? So even though it's been given to me as 24 meters per second, I want to use negative 24 as my rate of change. And what I don't have is my initial value, my y-intercept, the distance from the safe zone at 0 seconds. So I can use change in y over change in x to figure that out. So let's look at the table. The change in x is clear, it's 4. I don't have my change in y, but I do know that my change in y over change in x is negative 24. So negative 24 equals some number divided by 4. Negative 24 equals what number divided by 4? So I'll just multiply negative 24 times 4 to get negative 96. So then to figure out your initial value, you think, how many meters away from the safe zone was Rachel? Which when you subtract 96 meters away, you get to 76 meters. So let's just go in reverse and add, and we get 166 meters. That is my initial value. And so we have our equation of y equals negative 24x plus 166.